Card. At least they will only have missed that formula blank. Okay, what about, wait, we already said 4 standard deviations was 94%. What about 5 standard deviations? 96%. And now let's really up the ante and say 10 standard deviations. 99%. Now look how far it took us to get to 99% of the data. 10 standard deviations. 10. That's a long ways off, especially if you think of, let's say the standard deviation is 3. That means we would have to add 30 to our mean and subtract 30 from the mean to get 99% of the data. Bless you. Okay, let's look at an example. So for a sample of families with 1 preschool child, it was reported that the mean child care time per week was approximately 36 hours, with a standard deviation of 12 hours. So mean was 36, standard deviation is 12. Using Chebyshev's rule, at least 75% of the sample observations must be between 12 and 60 hours. So that's 2 standard deviations. At most, what percent of the observations are greater than 72 hours? Okay, for this, I have a workout slide for us to talk through it together. This can kind of get confusing. Okay, so there's our problem. So now, what I want us to do, we're going to kind of draw a picture of what's going on here. So what did they say the mean was? 36. Now, it doesn't have to be symmetric. I'm going to try to make it symmetric, just for the sake of the example. But remember, Chebyshev's can be used with any shape. Okay, if we label this using standard deviations, so our mean is 36. If I do my units here using going up by standard deviations, what would be my next? If I go 1 standard deviation above, what would I be at? 36 plus 12 is 48. What's 48 plus 12? And then 60 plus 12? And keep in mind, these are hours that we're dealing with here. Now let's do this below. So if I go down by 12, what will I end up with? Down by 12 again, and then down by 12 again. Can I go down again or no? Why can't I go down again? Can't have negative hours. I have to stop right here. How many standard deviations away is this 0? Bless you. How many jumps did I go? 3. So what the question is asking is what percent this is up here. What we need to do, though, is figure out, according to Chebyshev's, what is this percent down here? How much is all of that? Well, that's where Chebyshev's comes in. We said we moved 3 standard deviations each way, right? 36 down to 0 is 3. 36 up to 72 is 3. So let's calculate that percentage. So 100 times 1 minus, what is it, 1 over k squared? 1 over 3 squared. What does that give us? 89%. So that means that this area right here is 89% of our data. What does that leave us for up here? About 11%. That's what it's asking. That was our answer. 11% was our answer.
I was saying like the whole thing that you colored like green, that's going to be 89%.
That's going to be 89% according to Chebyshev. Yeah. Because we went 3 standard deviations each way. The what?
Like the median, or like the
Well, they gave us the mean.
Oh.
It's 36. They gave us that part. We just had to figure out, so they're talking about the 72 here. How many standard deviations do I have to go to get to 72? And then we had to go 3 up, so that means we had to go 3 down as well. But when you go 3 down, you get 0, and we said, wait, you can't go and have negative hours. So it has to stop at 0. Does that make sense? Okay, so the PowerPoint actually puts that in words. Don't know if the words will help or not, but there they are. At least 89% of the observations are between 0 and 72 hours. Since time can't be negative, at most 11% of the observations are above 72 hours.
Time could be negative and you just divide it into.
What's that?
Time could be negative and you just divide it into.
Yeah. If time can be negative, you would just divide it in half. Okay, questions on this example? Let's see, some trying to write, so I'll give you all a chance to get that written down. Did I get to practice yesterday, Riley?
Yes, sir.
Indoor?
No, sir.
No, yeah.
I gave us a studying. Yeah.
Oh, nice.
It was really nice weather. I'm hoping that it doesn't rain today, but I have a feeling that my luck ran out yesterday.
When I left, it was raining, so that's why I'm like, oh, I don't know if they got to practice or not.
Practice with us tomorrow when I was driving back home.
Okay. So this example, I didn't give y'all the data in your packet. You have it further up. Don't worry about it. We'll just talk about it. And then the chart that summarizes the data is what's on the bottom of page 16. So this is the student age data that we dealt with yesterday when doing all those histograms. So what they did is they calculated, for one, the mean, and then they looked at standard deviation. So how much data was within one standard deviation? Well, that's pretty much everything from 17 to 26. What was within two standard deviations? That was everything from 17 to 30. So it included the 28th and the 30. 3 standard deviations added the 37 to the full total. 4 standard deviations added 38 to the total. And then 5 standard deviations captured the rest of it.
So like, if it says like, where it says like within 2 standard deviations, the mean, I'm talking like from 12 to 36, or from like 36 to 50.
Are you talking about that last example we were on?
Are we on the same thing? Or no?
No, we're
Oh,
switching.
this was different.
This is
Okay.
different. On that last example, when it says within 2 standard deviations, yes, it's talking about 12 all the way from 12 to 60 is 2 standard deviations.
Oh, okay, I got you.
Because the 36 was in the middle, so we did 2 down, 2 up.
Yeah, and it's showing what percentage of it is the total amount of data.
Mm-hmm.
Okay, I understand.
You're welcome. Okay, so the purpose of bringing up this data was to show how inaccurate Chebyshevs can be. So how much has to be within 1 standard deviation of the mean? Chebyshev tells us at least 0% has to be within 1. Well, no, don't. I hope data is within 1 standard deviation of the mean. According to our data set, we actually had 91.1% of the data within 1 standard deviation. Within 2 standard deviations, as we found out through that exercise earlier, at least 75% had to be within that range. Our data actually had 94.9%. 3 standard deviations, we rounded up when we said it. We said 89. They used 88.8, but still, our data actually had 96.2%. And then they're eventually getting closer as we up the standard deviations. So within 5 was 100%. Chebyshev said it only had to be 96. So Chebyshev gives very conservative lower bounds. And the values aren't very close to the actual percentages. So in other words, if you wanted an approximate answer, Chebyshev probably wouldn't be a good rule. If you just wanted to know the minimum, then sure. But if you wanted to get close, I wouldn't use Chebyshevs. Okay, so here's where your calculators come in. This is where I said you need some kind of calculator, whether it's the 84 or the Inspire. If you don't have your 84 dual credit, make sure you have it Thursday. Okay. So this is called the What's My Area activity. What's my area? So we're gonna do a couple of them together. Because I'm gonna show y'all how to do this on the two different calculators. Okay, first we're going to do the 84s. Then we'll look at the inspires. Okay, so that goes away. Okay, so on your 84, we want to go to y equals. We'll hit the y equals button. And then to get the normal PDF, we have to hit second and vars, which is right there below the arrow. And it brings up your distribution menu. And if you're already kind of lost, the buttons that I've pushed so far are actually down here. If you're behind, the buttons pop up as I push them. Okay.
Where's Lars?
It's right next to the clear button, which is
Oh, I found this one.
variables.
Oh.
Yeah. So it's like where you can store different things as variables. Yep. Okay, we want normal PDF. So hit 1. And it's going to bring up what I call, or what really should be called, a wizard. If you've done any technology, especially in BIM, you may be familiar with wizards. It's like, I want it to do this. Okay, give me this info. And then it does it for you. It was. Okay, so in your case, you can actually enter exactly at that point what's on the paper, what's on the handout. So the X, comma, 20. Yep. Yep. If it doesn't give you this wizard and it just comes up and says normal y equals normal PDF, then you can actually enter exactly what's on the paper, X, comma, 20, comma, 30. If it gives you the wizard, we're still going to enter those 3 numbers. We're just going to put them where it asks for it. So the X value, well, we want to use X. And how do you get X? It's right next to the alpha button. So this one on my screen that's kind of in red right there. Then we'll hit enter. What does mu stand for? Let's try to remember our terminology. What does mu stand for? That's the mean. So here, what did they say our mean was on this example? 20. Okay, so we're going to put 20 there. And enter. What sigma stand for? Standard deviation. That one's going to be 3. So once we get that, we paste it in there and it'll plug it in for us. Now, if that menu didn't pop up, you just type in, like I said, X, comma, 20, comma, 3. And then hit enter, yes. Now, we need to change our window, because if we graph it just like this, it's going to look like nothing happened. It's graphed, but can you see anything? No, because we need to change our window. So let's go to window. And on the notes, what does it say the X minimum needs to be? What does it say set the window to?
10:30.
10 to 30. So X minimum is 10? Nope, just 10. We hit the window button up here. X maximum is 30. That scale, just leave it as 1. Don't change that. So Y minimum, I think it said what, 0? Okay. Y maximum is 0.2. Now let's try graphing and see if we can see something. So did your normal come up like that? Yep. And then hit graph. No? Okay, so in Y equals, do you have normal PDF? Okay. What I can do is I'll get us started on the activity where y'all, those that figured it out can calculate it, and I can help you see what's going on. Okay, so once we get it graphed, those that have it graphed already, the directions on the paper tell you exactly what to do. You go to second, trace, and 7. If you've taken calculus, you probably recognize that symbol when we hit 7. What we're actually about to do here is take the integral under the curve. Second trace and then 7. Then does it ask you for lower limit? Okay. So what does it tell us to do for the first lower limit? What? Yes, but what's the paper tell us? For that first blank. 17?
Oh, right there. Oh.
17 and 23. So lower limit, we're going to actually type 17. That way it's exactly 17. How do you? Yeah. Hit enter. And then it asks you, okay, what's your upper limit? And the paper says we need to do 23. So let's type 23. Then hit enter. So that's the area under the curve. 0.6827. Okay, so that's how you do it on the TI-84. So if you understand how to do it, I want y'all to fill in the next 5 blanks. Notice the last 3 it asks you to put in a different normal PDF. Now I'm going to show the inspires. That way y'all know both ways. Okay, so on the inspire, of course, we need to go to the graph. And then we'll hit the little book button, which is right there below the delete key. Looks like a book. If you can't see the book, watch my screen, and the button that turns red is where we click. Right there. Now you can, once this pops up, go to 1 on the menu up here. And then you can type in and it'll take you down to end. I used this last period, so I kind of was already there. But let's say it wasn't. You can hit N and drop down into the ends and look for norm PDF. Once you get that selected, you'll hit enter. If I'm going too fast, y'all just speak up. So then that comes up. Okay, well, enter your values. Then we'll have to enter X, comma, 20, comma, 3. And then you'll hit enter. And notice it looks like it didn't do anything. It just drew a line across. But just like we did on the 84s, we're going to have to change the scale. So you'll hit menu. Go to Windows Zoom. And then Windows Settings, number 1. And we need to set our X minimum and X maximums. So 10 is our minimum. 30 is our maximum. Leave the scale at auto. Y minimum 0. Y maximum 0.2. Then hit OK, and it should pop up for you. Move that out of the way. Okay, so now let's find the area under the curve like we need. So we'll hit menu again. Analyze graph. And then integral. Option 6. Bless you. And it's kind of like what we had on the 84, like I just showed. It asks for a lower boundary. So we want 17 for our lower bound. I just actually typed it, 17. And enter. And then it asks for an upper bound. We want 23. Hit enter. And you should have gotten 0.683.
we always be told what the lower numbers on the side? Just for this one.
I need to double check on that. I don't want to say yes or no. I need to double check. Right now, this is just an activity because what we're setting up is another rule. But I don't mind. Okay, so try those other 5 right quick. And I'll walk around, and if you're stuck on how to do something, I'll help you with whatever calculator you have. Yes, you can. Okay, we need to be in Y equal. Yes, you're just trying to rub it off. On there. So, yeah, next column. Now do your window. Yep. Second, trace 7. Trace. That one. And 7. Your lower limit, what does it say? Let's do this one. 14. Just type 14. And hit enter.
14
Oh, and then upper, it says 26. That's fine. And what does it say to this? Yep, you want to do that one too? So for the last 3, you'll have to change your normal PDF. But I want y'all to try to fill them in. And then see if you notice something special about it. Bernice, you were saying you needed help?
No, I can't.
We got it graphed, so let's do second trace. And 7. That's your lower limit, so 17. Just type, you can just type 17. Uh-huh. And limit. Yep. So round it to 4 decimal places. For the second and third, you don't have to redo the whole process. You can just go to second trace 7 again. You won't have to redo the process until you get down to a new one. Uh-huh. You have a question? Everyone knows how to do it in one of the calculators at least? Okay. How far did we get to?
Oh, I've been,
No, it's the second.
okay, I don't like to verify it.
Yeah, and you're using for that.
There, but,
What?
That's fine.
Wait, so is it the second eight or is it the
Okay, so. You need
To go slightly further.
Okay, so
Like, I do the same thing.
we'll bring here, we'll get
So
menu,
that's what you're gonna do. You don't
and
have
off
to-
ramp,
So we're just going further.
Yeah, we're just like,
And then-
I just did the,
and then ask you for your lower bound, and then just type in your lower bound,
And you have to go in.
type 14, and enter.
chopping this piece.
And then ask you. You got 0 for
This is the was original.
Yeah, yeah. Thanks, because it's the same area.
Convention.
7, 9, 5, 4.
Seven.
Yep, that's right. That's 9, 5, 4. That's right.
So it's 60.
Yes.
9%.
Okay, so what we can do is hit menu, analyze graph, integral, and then when it asks for lower bound, adjust. Yep. Mhm. That's it. Yep. You're welcome.
So you need to know the G.
You don't have to actually do the normal PDF to do that one again.
The
You
rule
can
is
just
70.
just do the menu.
Yeah, which is really good.
Yeah.
I didn't know. But
The only time you'll have to repeat it
This
is
is
when
like
it gives you a new
70 over.
You're welcome.
Like 2% would be 70 over 2. That's how many years it takes worth of that. And then, you also need to know price and the,
Oh, yeah, like just the local.
yeah, nominal GDP or GDP, and then price market, or market basket price. And then,
That sounds like macroeconomics.
it doesn't have to.
Y'all were saying market basket price, I'm like, this looks like y'all talking about GDP or something.
Yeah.
Yeah.
There's a, economic.
You want to do that first?
That's it.
And then clear.
Yeah. Yeah. Okay, I do my breakdown now.
Okay. So let's talk about what we got here. I know some of y'all may not be finished, but we've got to keep it moving. Okay, so for that first one, what did we say the area was? The one we did together.
For the 17 to 23.
17 to 23, yeah.
0.6827.
0.6827. Okay. What about the next one? 0.95. 44. The next one? 0.997. And I'm going to add the extra 3. I know if you did it on the Inspire, you didn't see that extra digit. Okay. Now, if you made it to the next group, help us fill these in. They're all the same? Oh.
Isn't there a rule like this in calculus?
I got 83. It's 0.683 on the first one.
Which calculator did you do it on?
That's fine.
Okay, yeah, so what they did is this, since
I just rounded it up.
they just rounded it up, yeah. Yep, so if you got 0.683 on the Inspire, that's still right. It's just you only saw 3 decimal places, to where, like if you did it on the 84s, it showed a lot more than 3. Okay, what do we notice? If our mean in each case, well, the first case the mean was 20. How many standard deviations were we on the first one away from 20? So, mean was 20, standard deviation was 3. So how many were we away on this first one? 20 to 17 is how many? That's 1 standard deviation. What about the next one? How many standard deviations away were we? Well, how far is 20 from 14? 6. 6 divided by 3 is what? 2. So the next one, we're 2 standard deviations away. What do y'all think about the third one? How many standard deviations away are we? 9 divided by 3 is 3. Okay? Now let's look at this next group of problems. This one, we changed it. The mean was 50. Standard deviation was 5. So how many standard deviations for this first group? 1. What about the second group? 2. And the third group? 3. So you probably notice there's something going on here. Each time you're 3 standard deviations away, you get the same percent under the curve. Each time you're 2, you get the same percent. First we're going to mention one more thing about Chebyshevs, and then we'll talk about the pattern. Okay, so Chebyshev says that 75% of the observations in the data set are within 2 standard deviations. What did we find for the percent for 2 standard deviations? with the activity we just did. About 95%. So that's way more than the 75 that Chebyshev said. That's because there's another rule called the empirical rule. Pretty close, yep. So now notice the empirical rule can only be used with distributions that are mound shaped, meaning they're approximately normal. Normal and symmetric. So empirical rule only works with normal, approximately normal distributions. It says that approximately 68% of the observations are within one standard deviation. So 68% are within one on each side. 95% are within two standard deviations. So we cover even more. And then 99.7% are within three standard deviations. Almost all of it, basically.
Why is there a decimal on the last one?
To show that we're pretty much, that there's only 0.3% that isn't captured here. To show that almost all of your data will be within three standard deviations. If it's normal. There's only that slim 0.3%. And so what we're actually going to talk about on the next page, if we're more than three standard deviations away from the mean, that's why it's so unusual. Because 99.7% of your data should be within three standard deviations. If it's not, or if you get a point that's not, it's like, that's pretty rare. Okay, so they give you a nice little chart to help break up the different areas that we just talked about. That's what?
That's how they figure out scores for the AP test, right? It's like 60-something% makes it 3, and then
They kind of use the bell curve for the AP test. Most make 3s. A few make 4. This would be like your 4s. This is how many 5s there are. That's how many make 2s. That's how many make 1s. So, yep. Okay, so next example. The height of male students at PWSH is approximately normal with a mean of 71 and a standard deviation of 2.5 inches. What percent of the males are shorter than 66 inches? Okay, last period what we did, what helped a lot of them, was actually drawing your graph out. That helped quite a few of them. So we're going to do just a quick sketch of it. So the mean was at what? 71. Okay, so if I add 2.5 to 71, what do I get? 73.5. I'm going to add 2.5 again, what do I get? 76. Add 2.5 again, what do I get? Okay, there's the upper end. Now, go in reverse. So subtract 2.5 from 71. 68.5. Subtract 2.5 again. Subtract 2.5 one more time. Now let's use that empirical rule chart that we had on the last page and actually break this up into our percentages. Right now it seems like we may be doing a lot of pointless work, but when we start answering questions, you'll be glad we did this. Yes, I know there's a line tool. I just thought about it after I'm already done doing all my dots. Okay, so on that chart, let's label our percentages based on that empirical rule on the previous page. So these two big areas, what are they each? How many percentages are they each?
34%.
34%. Then you go out one, and it's 13.5%. And you go out one,
2.4.
and then the last bit that just leaves us with 0.1% outside. Okay, so let's actually look at the questions now. What percent of the males are shorter than 66 inches? That's right. We just look here. Shorter than 66, you do 2.4 plus 0.1, and you'll get about 2.5%. Because remember, these are all approximations. They're close approximations, but they're still approximate. Okay, what about taller than 73.5? It'd be about 16%. So we just added these up. For that first one, we added these up. So this is A, that's B. Now C asks how many are in between 66 and 73.5? How many is in that range? Let's see, we have 34, and 13.5. I'm totally not lining those up.
I was adding 37.5.
11, carry your 1. 81.5%. That's right. So about 81.5%. I will say, dual credit, you'll need to know these percentages for the test. So, I don't know if you want to circle them, store them, whatever you want to do. This is one thing to for sure study between now and Thursday.
Like these exact percentages?
Yes,
On the graph.
on the graph. So basically know the bullet points about the empirical rule. The 68, 95, 99.7. Know those. Okay, Questions on this example? Gotta keep it moving. Okay, so the empirical rule versus Chebyshev's. The empirical rule makes approximately instead of at least statements. And the percentages for K equals 1, 2, and 3 standard deviations are much higher than what Chebyshev's allows. We saw that. We saw they were, we were at 99.7% within 3 standard deviations. Yes.
Are there any situations when Chebyshev's rule is better? Or
If you're wanting a lower boundary, then Chebyshev's would be the better one. If you're wanting a lower boundary, like what's the least it could be, Chebyshev's would be the one to use. If you're wanting to get a close approximation, empirical rule. And also, remember, empirical rule has to be normal or approximately normal. Chebyshev's can be anything. So, and that's why Chebyshev's is so loose, because it can be anything. Empirical rule, it must be normal. In contrast to Chebyshev's rule, dividing the percentages in half is permissible this time because the normal curve is symmetric. So on Chebyshev's, unless you know specific information about the distribution, you really can't divide percentages in half. So I told you wrong earlier. You asked about dividing in half. On Chebyshev, you can't, because we don't, unless they tell you it's symmetric, you can't just assume it is. It can be skewed.
if you're given the entire graph, could you then assume it's symmetric?
If you're given the entire graph, you can look at it, and yeah.
But if you're just given part of it, you can't assume.
If you're just given, this is the mean, this is the standard deviation, and you're not told anything, then you can't assume. Because if it's normal, it'll tell you, assume this comes from a symmetric distribution. Okay, another reminder, the empirical rule can only be used if the histogram of values in the data set is reasonably symmetric and unimodal. That's one of your blanks on page 18. Symmetric and unimodal. Specifically, we need it to reasonably approximate the normal curve. And no matter whether you're in dual credit or AP, you'll start seeing in problems now, assume the data is normal. Assume it's normally distributed. That's why they tell you this stuff. It's unusual to see an observation that's further than 2 standard deviations from the mean. Because if we remember, there's only, within 2 is 95%, so outside of 2, there's only a 5% shot of seeing that. If you go more than 3 standard deviations away, there's 0.3%. So it's even rarer to see more than 3 standard deviations away. So that, in case you didn't catch it, that bolded 2 right there is a blank. Okay, z-scores. We're going to have to get through these. We're going to have to zip through these because of time. The z-score is how many standard deviations the observation is from the mean. A positive z-score indicates the observation is above the mean. Negative z-scores mean it's below the mean. And to calculate it for a particular observation, we'll take the observation minus the mean divided by the standard deviation. So to get the z-score, it's observation minus mean divided by your standard deviation.
So like, from like a terms point of view, like symbols, wouldn't it be like n minus mu over s? Not correct?
You're close. You're really close. We're actually going to see it in symbols here in a short second.
Okay.
Yeah, you're close. Okay, so let's kind of interpret these z-scores. If a z-score was negative 2.3, how can we put that in words? What does that negative 2.3 mean?
Below the mean,
How far below the mean?
2.3.
2.3 what?
Standard deviation.
2.3 standard deviations below the mean. That's right. That's what negative 2.3 means as a z-score. What about 1.8? It'll be 1.8 standard deviations above the mean. And then negative 4.3.
Below,
Okay, what would the whole phrase be?
4.3 standard deviation below the mean.
That's right. 4.3 standard deviations below the mean. Okay, so Raleigh earlier was asking how, okay, so great, we know the formula for z-scores, but how do you put it in symbols? Well, computing the z-score is often referred to standardization, and the z-score is called a standardized score. So the formula that we use for sample data is that z-score equals x minus x bar divided by x. X is our observation. X bar, so this is that part that's on the very bottom of page 18. X bar is your mean. S is your sample standard deviation. So x minus x bar divided by s.
And what does the x minus x bar mean, you said?
So x is our observation, our individual observation. X bar is our mean of the sample,
Okay.
and the s is the standard deviation.
So when would you use x bar and when would you use mu?
Mu is population.
And then
X bar is sample.
Okay. Gotcha.
Is there a difference between S and, I can't remember the name of it.
Sigma?
No, No, the O thing with the line.
Sigma.
It's called sigma. The sigma was the minus one sigma.
Well, the capital, the one that looks like an E, that's a capital sigma. The lowercase sigma is the O with the line.
Oh, okay.
Yes, so that's actually similar thing to what Riley asked. Sigma, the O with the line is population standard deviation. S is sample standard
When I
deviation.
was doing, I'm sure I used sigma. That's what I found out.
Yeah. Okay, let's look at an example. So Sally is taking two different math achievement tests with different means and standard deviations. The mean score on test A was a 56 with a standard deviation of 3.5. While the mean score on test B was a 65 with a standard deviation of 2.8. Sally made a 62 on test A, a 69 on test B. Which test did she score the best on? Okay, so why don't we try to digest what all this means, what all this gibberish means. Let's see if I can. Let's go back. Okay, so what's our score that Sally made on test A?
56,
The 56 is the mean score, that's the average.
Oh,
She made a 62. So we need to standardize these. So we're going to do her 62 minus, what was the average on test A? 56. And then we've got to divide that by the standard deviation, which was a 3.5. So that calculation would look like that. I'll kind of just give y'all that one for test A. So 62 minus 56 divided by 3.5.
that gives us a Z-score?
That gives us the Z-score, that's right. And that would get you 1.714. Now I want y'all to take about 30 seconds because we're running out of time. Calculate the Z-score for test B. One point.
14.42.
Yeah.
34.29.
429. So, which test did she do better on? Test A. She was further away from the average on test A. So, she did better on test A. This is like what? Okay, then we have one last example that I'm going to try to squeeze in before the bell.
Okay.
So percentiles. Percentiles basically are how many observations are at or below that point. What percent? So if you make a 78, you're in the 78th percentile. that means that you scored better than 78% of the people. Simple enough, right? So, this last example, they ask what percent of newborns have a head circumference greater than 37 centimeters? If we look at the chart, 37 centimeters is the 75th percentile, meaning 75% had less than 37. So how many had more than 37?
25%.
25%. Then it said 10% have head circumferences bigger than what value? 38.2. 10% plus 90% give you 100. So we look at the 90. That's at 38.2. Okay, barely got it in there.
So,
Yes. Yes.
I'm sure about that.
You too.
But I thought it was 6.
I got it first, and I got something really small now.